Welcome everyone to the Secure Shell Maintenance Working Group session at IETF 122 in Thailand. Yeah. Okay. Yeah. Cool. Let me see. So Simon, I really enjoy seeing you on the camera, but I'm gonna make your screen disappear. Is Deb in the room? Oh, sorry, you were hiding behind.
Well, I just walked in.
All right, we're complete. We can start. So remotely with my co-chair, Stefan Farrell. I very much appreciate that you got up this early to grace us with your presence. All right, let's start. So many of you have probably seen throughout the week slides with the concept of note well. As we gather here, we follow the IETF process, and part of the IETF process is that we have various policies and guidelines to which we abide to constructively work together. Here is an overview of information that applies to our meetings and the mailing list. Part of the note well also is that you indicate your presence in this room by scanning the QR code that's hanging off the microphones. This will help us plan the size of the room at the next meeting. And then we'd like to divert a little bit of attention to note really well. Over the last few months, there have been various discussions on the mailing list. Some of them I followed with great enthusiasm, and I was impressed by the engineering involved to carry conversations, how exactly things should look on the wire or how state machines should behave. Those conversations, to me, are fantastic. It doesn't matter how many emails are spent to try and figure out these technical details, love them. But we've also seen a number of conversations where the concourse between participants is not optimal, and chairs unfortunately receive a substantial number of complaints from people complaining about each other, and then people complaining about other people complaining, and people complaining about other people complaining. Now, you all laugh, but you have to realize that I sit here as a volunteer and I have to read all these dreadful emails. So if anything, have pity on your fellow working group participants, but especially us as chairs when you hit send on emails. Now, I've attended IETF meetings for, I think, more than 10 years. And in my experience, working groups can sort of have a seasonal effect where sometimes discussions flare up on a particular topic, but once the topic is settled, then the concourse moves on to more enjoyable pastures. And my hope very much is that we'll get to the greener side of the hill. Stefan, is there?
Yeah, I just want to second what you're saying, Job. So I think there's two kind of key things that I'd kind of ask people to bear in mind. One is to please do not try and speculate about the motives of other working group participants, because that's a thing that has caused people to flare up a number of times. So if you see that somebody has made a decision with which you don't agree, there's really no need and no benefit in trying to speculate why they made that decision or to ascribe motives to them generally. So I think that's one thing that we need to be a bit better about. So don't comment on people's motives, what you think they are. You don't know what they are. And I think secondly is let's not take the bait when somebody else does that. Another thing we've noticed is that if somebody does kind of go a little bit off the trail and does kind of say that was a stupid decision or make some commentary like that, then a number of people are immediately kind of jumping in, being offended by that and reacting to it, whether that's on the list or off the list. So first thing, let's not do the misbehavior of ascribing motives to others. And secondly, if other people do that, just don't take the bait. I think if we could improve in those two ways, then I think we could tame this whole thing down a good bit and make better progress. So I can appeal to everybody to please consider that bit of better behavior and note it really well.
Thank you for that. So in summary, people strive to be excellent towards each other. And if somehow we as a working group fail to find a dynamic that is palatable to everybody involved, the chairs will consider options like applying moderation to the mailing list and coaching individual submitters of messages like, hey, is this really what you want to share with the public? So we're on it, and I hope you as participants will remember how fun it was to be together in Thailand and carry that warm feeling forward until the next meeting where we can meet each other face to face.
So, Joe, I see in the chat that DKG has been helping out with minutes. Thanks, DKG, in the hedge doc, and is asking, is there somebody else who'd like to help with just keeping a few notes in the hedge doc?
Thank you so much, Rich. Much appreciated.
Thank you, Rich.
It appears somebody's trying to share slides. No need to do that. I will manage the slides from the laptop right here. All right, next slide. Let's see. Audio, no, that's all good. Our agenda for today. We have this slide deck where us chairs lament about how hard our job is. Today there's basically two structured presentations from Damien on the Terrapin attack and how to mitigate the impacts of this protocol vulnerability, and some thoughts on the certificate format. I don't think we expect these two presentations to take up the full 85 minutes that we have left in the session. So there will be some time for any other business at the end of these presentations. But if there's no other business, then this session will just be a little bit shorter than the 90 minutes we have allocated for it. Does anybody have anything they'd like to add to the agenda at this time? No? Okay. Document status. So in the last few weeks, we had extensive discussions about the use of NTRU prime in SSH. The working group last call phase has ended. To summarize what transpired over the last few weeks, Simon Josephson and his co-authors put forward an internet draft that outlines how to use the NTRU prime algorithm in SSH. As part of the publication process, this document is then put up for what is called working group last call. This is an opportunity for people to, it's now or never, hold your silence or object. So there were a lot of comments on some aspects of the draft, particularly the intended document status, whether it should be standards track or informational or something else, and how the algorithm should be referenced in the IANA registry around the key exchange algorithms. in this working group last call, we received a number of positions from people where a subset of people are like, it must be this, or it should be that, or it may be that. The chairs went through all the mails and concluded that the recommendation for the IANA registry is that it should be marked as a should. EKR Ecker disagreed with the conclusion of the chairs in our interpretation of the consensus and used a mechanism that is known as an appeal. And the IETF is structured in a little bit of a hierarchical sense way. You have the working group chairs, me and Stefan. We are helped by Deb Cooley, our area director, and she is part of the IESG. So if there is any disagreement about procedures or anything at all, there is an escalation level available where you can indicate that you disagree with a certain outcome, your argumentation in favor of that, and then someone other than the entity you disagree with will take a look at the situation. So an appeal was filed. This is good. It's very nice that this process is available to us. As part of the outcome of handling this appeal, it was decided that we'd ask the working group a specific question on what the IANA registry marking should be for NTRU prime and ask people to indicate their position. The reason we asked this was that throughout the discussion in working group last call, a number of people communicated fairly nuanced positions where, for instance, one could say, I think it should be marked in this particular way if this other condition also happens. For instance, another document also receives a similar marking. But throughout this process, we did notice that some people expressed slightly different positions at different times. So it felt prudent to try and get more clarity on where everybody exactly stands. Now, the outcome of the poll, in the opinion of the chairs and the area director, was that the should marking in the IANA registry is consistent with the working group consensus as we perceive it at this point in time. So we can proceed in that regard. The next step for this document is on my desk. I will write a so-called Shepherd write-up. And in this write-up, I will try and summarize the discussions that took place along the progression of this document, and I will make mention of the appeal and add some references for other folks to review when they consider publication of this document. So I will write a report that the IESG, Deb and her colleagues will use as input to decide what the next step is for this document. So thank you all for participating in the working group last call for this particular document. But yeah, this working group essentially now is done with NTRU prime and is now up to other bodies within the IETF. We have other documents in the pipeline. There is a draft about using Cha-Cha 20 and
So Joe, we have Taro in the queue.
Taro, I did send some comments on during the working group last call, and they haven't been applied to the draft or actually even acknowledged by the author. So I would actually like to know, are they going to be ignored, or are the authors actually going to go through those? And I think there might have been actually some other people also making comments. It might have actually get lost in the heated discussion of other things.
Absolutely. So thank you for reiterating this point. As part of the Shepherd write-up, I will try and understand, has all commentary at least been acknowledged, or preferably been addressed in a way that is consistent with the desires of the authors and the commenter. So I think the message you're referring to is you had some editorial comments where you said, for instance, like, hey, instead of just referencing bare RFC numbers, reference the title and the RFC number. So as part of the Shepherd write-up, I will try to make sure that commentary like you offered is addressed. So there will be another revision uploaded, and you should see some progress in that. And you're absolutely right that in the flurry of emails, I think there was probably 200 plus emails. At some point, some of the readership does get overwhelmed and loses track of what the outstanding to-do items are. So my hope is that I can organize the spaghetti into straight lines and make it palatable for everybody. So yes, that is your comments will be considered.
So actually, I have one question. Do you want us to actually, you know, if other people have comments, do you want us to send, you know, repeat them on the list and saying these are the comments that might have get lost, or do you want to dig it out yourself? I was just, you know, helping you to find out those things that are there, because I think if somebody else said something, I might have missed that, and you might have missed that. So I was thinking about, would it be useful?
For this particular project, I would encourage you to just wait for the next revision. And if me and the authors did miss things where you feel it's of critical importance, then just raise it.
Do we have, or could we have a GitHub for technical issues to separate that from the political views and keeping track of the technical, like Tero's comments? Also, was there any conclusion from the working group last call on the informational or standard tracks? Maybe you mentioned that. In that case, I missed it.
Yeah. There was a conclusion, and the conclusion is that NTRU prime should be marked on, should be published on the informational track with a should marking in the IANA registry. Your comments as to using GitHub or not, at the last meeting, and I don't remember the country anymore, but we agreed that it is up
that was
to
here, Joe.
Sorry?
The last meeting was here.
Right, Dublin. Yeah. It vaguely rings a bell. Yeah. But we did discuss, like, should we how do we organize this working group? And as chairs, we advised the working group, if you as author should use the tools that you feel comfortable with using. So if you want to organize your internet draft project via GitHub and track it in issues, all power to you. As chair, I'm happy to open GitHub links and take a look at things. To me, it doesn't matter that much. But if you prefer another mechanism, like your own GitLab instance, or you just want to use the mailing list and a text file along the side, it's up to the document authors how they want to organize things. As chairs, we'll try to make sure that all comments that passed through, that were shared with the mailing list in, for instance, working group last call or other phases of the document, that they are addressed. And if people have the feeling that their comments were missed somehow, you can always approach the chairs. But GitHub use is just optional. And some people really like to use it, and some don't, and both is fine. Like, I think bug trackers have been a challenge in computer science for the last 60 years, and I don't expect this working group to find the solution that works well for everyone. Hey, and for instance, the working group's charter was largely constructed using GitHub. So, you know, for some documents it works well, and we do use it, but it's not mandatory. All right, so that covers NTRU prime. We have other documents in the pipeline, one around ciphers, one about SSH agent protocol, and one about MLChem. And I think that we as working group need to decide, like, what is what should we take on next? Like, should we pick something that is not super controversial, or should we pick something that is going to require in-depth discussion to progress? Your feedback is welcome, and it also strongly depends on where the authors believe a document is. So as chairs, we don't have exact insight into the maturity of a specific document. Like, is it implemented in multiple implementations or not? We depend on the authors to tell us, like, hey, we think this document is ready for the next phase. Can you as chairs help the progress? Alicia Cario, I don't know if I'm pronouncing your name correctly, is suggesting MLChem is highest priority. Bob says, I don't agree. Stefan, I guess we want authors of documents to tell us whether they want to take the next step. I think the onus should be on the authors. The authors have a duty to their own project and to the working group to attempt to progress things that are compliant with the charter and our publication requirements, for instance, multiple implementations. So I'm hoping authors will tell the chairs what to do next.
Sure, but it's also fine if people just working group participants want to express opinions to the chairs or on the list and say, let's prioritize this versus that. That's all good. Paul?
Paul, the speaker's individual. Isn't there a relationship between the Cha-Cha 20 poly draft and the strict CACs? Should the strict CACs not at least either fold into that document or become a normative reference? So that might depend the order in which you do things.
Sure.
Yes. The ordering, there are interdocument dependencies, and for instance, as part of the Cha-Cha poly adoption call, somebody indicated, I'm in favor of adoption, but before we proceed to publication, we must also have specified the strict CACs approach. So if the Cha-Cha offers then add that as a normative reference, then of course what is in IETF parlance called a cluster of documents comes into existence, and that means that multiple documents must move in concord together in order to get published. So a bunch of these dependencies sort of are automatically resolved through the data tracker, telling us like, hey, this thing also needs to progress to a certain point. I did see a comment from Daniel Gilmore in the chat who asks, these are all draft IETF SSHM. Are they not already adopted? Correct. The lower three documents are adopted. So the question is not should they be re-adopted, but when should they go into working group last call? And the authors of these drafts need to tell the chairs when exactly that is. Yeah, and by the way, I think the Cha-Cha poly adoption process and then subsequently somebody writing down how strict CACs should be and that there is a relation between these two documents, I think that is a really good example of this working group being efficient. And as we go unwind, like what does it take to properly standardize the mitigations for progressive insights into the SSH protocol. So I was very pleased to see these documents materialize as they did. We have Scott.
Yes, you just said that the charter of the working group was simply to document what the current SSH protocol in practice was used. On the other hand, if you read the charter text, it specifically says that defining how SSH uses cryptographic algorithms is in scope, including I assume that means cryptographic algorithms which are not currently used.
I'm a little bit confused because you said that I
believe
referenced the chat.
I believe you stated, at least that's what I heard, that you said that this group's charter is to document what the SSH protocol is in practice. And that is, in fact, I believe it says it is an initial goal, but it doesn't say that is what we are limited to. Did I
think Bob said something in the chat about the charter, but I don't think I mentioned the charter.
Did I misunderstand? Okay.
Yeah, maybe there's a bit of miscommunication.
Yeah, we're not ruling MLChem out of charter or anything like that. The working group have adopted the draft, so it'll we'll progress it. We're on. We do require. Well, not required. We do really want authors to say, "I think this is ready," and that'll give us a good heads up as to what to do next as chairs.
Okay, so to be specific, if is Panos in the room? I know. So he's the primary author of MLChem hybrid kex. If he, as lead on this project, is like, hey, there's an implementation in this distribution, and there's an implementation by a different group of people in this other project, hopefully even another language, and we have not updated the draft's text for a while, so we sort of feel like it's stable, or we haven't received comments in a few weeks or a few months, whatever is appropriate. They could send a simple message to the chairs like, hey, we feel this project is ready to move forward. Can you start a working group last call? The chairs would then see what the agenda is like. Are there other working group last calls also ongoing at this moment? Or are we like just before an IETF meeting or just after? I don't know. We'll do some assessment of the time schedule and what we think fits within the working group's bandwidth. And then a working group last call could be kicked off. But I guess the point I'm trying to bring across is that the initiative to progress things to working group last call primarily is with the authors of a draft, but not exclusively. I mean, yeah, there's a bit fluidity in this process. Okay, we have in queue Ecker.
Yeah, I just like to suggest.
What do you prefer, Eric?
It doesn't matter. I just like to suggest like not much is at stake in what's in the priority discussion here. As you say, when the drafts are ready, people will ask for them to be approved, or you should ask for them to be forwarded. It's not like there's like a shortage of bandwidth. I mean, you were just saying earlier, you think we're going to end early, so I don't think we have to worry too much about the highest priority, as people can push things along at the rate they want them pushed. I do think that may become relevant if we ask for adoption of a lot of other drafts, and I think probably, my sense is these drafts are higher priority than most of the things I've seen suggested for adoption. But maybe others may feel differently. But I think in terms of like, I don't think we'd like argue about the highest priority, as people will figure it out for themselves.
Yep, thank you. All right. Now, with that, I would say let's get Damien on the stage.
Do I get a clicker?
Absolutely. The setup this meeting is so luxurious because they have a tiny computer somewhere that's hooked up to the system. So independent of my laptop, you get a clicker, and that is super.
I know. I thought I was just getting special treatment in SAG. All right, so this is the first of two presentations I'm going to do. This one's on the strict kex extension and the cherubin attack. My people in SAG heard this yesterday, but my one joke about the SSH protocol is that it's staggered out of the 1990s along with TLS and IPsec, and it's very much 1990s crypto. Despite that, it's done pretty well over the last quarter century. And some of that has had to do with the academic review it's had over its lifetime. We've had a number of people elect to spend quite a bit of analysis and to the point of doing their PhDs on the SSH protocol, and I personally am really grateful for that level of review. We don't have something like a machine checkable proof in the form of TLS, but we got pretty close, I think, with the work of the academic community. CBC cipher modes are an exception to that, but they're more generally broken. We thought SSH was doing pretty well, that we were on a pretty good footing with the transport, but along comes Fabian, Marcus, and Jorg from Ruhr University Bochum with the Terrapin attack last year, which is a really cool attack. And spoilers, it doesn't have a huge amount of real-world impact, but has quite significant, cryptographic impact if you care about it, and I think you probably should. So I'll just a bit of background to understand the attack. I'll build up to it. The SSH protocol starts with the client and server exchanging text banners. You've probably seen those if you've spent any time messing around with it. Right after that, it drops into a packetized protocol and typically starts up a key exchange process, key agreement, KEM if you're using post-quantum, where the client and server...
Sorry, Damien. We need a little bit more.
Got to eat the mic, don't I?
Yeah.
Pity the person who speaks into this
Yeah,
after
this
me.
is better. Thank you.
So the client and server start with a KEX, we call it KEX, key exchange. Start by sending parameter negotiation messages, KEX in it, and then typically they do an ECDH exchange or run a KEM and signal completion of the KEX phase with the new keys message. Every packet has a sequence number. This sequence number is implicit and doesn't really appear on the wire at all, with one kind of very minor exception. And the original RFC 4253 specified that it does not get reset across key exchange. The key exchange is bound to the connection instance through an exchange hash. This takes in key values that as part of the parameter negotiation, the server banners, the ECDH or the public values from whatever underlying key agreement is occurring, and the shared secret that was derived by it. This captures pretty much everything, right? No, it's not a full session transcript. It doesn't capture everything that's sent on the wire. If you send a different packet during the key exchange phase, that would not be captured in the transcript. If you appended data to one of the existing packets, that would not be captured in the transcript either. But you can't send any other messages, right? You can only send KEX messages. No, you can send other messages too, but they look pretty harmless. Like ignore this message, maybe display this text to the user. They can't do anything, right? You can see where I'm going. They increment the packet sequence number. They have that side effect. The packet sequence number is not checked in any way prior to or at the completion of key exchange. And even afterwards, it's mostly implicit. So what can you do with this, right? You can, an on-path attacker, monster in the middle, can do some, do a very limited break of the SSH channel transport integrity. So this is what the early protocol looks like from the perspective of the client. Yep, the client. KEX in it is the parameter negotiation. It contains lists of algorithms the server will send one to. Actually, this is the server's packet trace, not the client. So client will send typically like for elliptic curve Diffie-Hellman, it'll send an ECDH init packet. Server will send a reply. Both ends will send new keys messages, which is a sequencing point in the protocol that says everything after this is using the new keys that were negotiated. and then move on to the next phase of the protocol. So typically a server will send an extinfo message, which is RFC 8308, I think, which is a kind of way of shoehorning stuff that should have been in the initial key agreement parameter negotiation into the protocol, but we didn't think of it back in 2003 or whatever. And then the client will send a user auth service request. It says, I want to start authenticating the user, and the server will send a service request, a service accept message acknowledging that. So the monster in the middle can insert, this is the essence of the Terrapin attack. An on-path attacker can insert a message prior to the completion of key exchange, and then one or more messages prior to the completion of key exchange, and then delete an equivalent number of messages after key exchange completes. So there's some caveats to this, which I'll get to in a minute, but this is kind of the essence of it. The peer will see identical, well, to the extent that it sees sequence numbers, which it doesn't, but the peer would have an identical notion of the sequence numbers, because the deletions undo the damage that was made earlier by the inserted messages. So I guess there's one like this attacker can do two things here. One which I've mentioned in the slides, and one which was pointed out to me after I sent round a draft for strict KEX by one of the authors of the Terrapin attack. The main thing they can do is delete messages. This is the thing which affects most implementations. Fortunately, they can't really delete much. If they were to delete, for example, that service accept message that I mentioned a moment, then the client will never get notification that user authentication can start now, and won't progress the connection. So they can deny service on a connection they can already deny service on by virtue of being on path. If they delete the extinfo message, they get to delete some of the post-KEX parameter negotiation that can happen in the SSH protocol, and I'll talk about what's in that in a second. One more thing that they can do is more generally, they can insert messages before completion of key exchange, which might have other effects on the connection. They shouldn't, per the spec, but at least one implementation was found to have a state machine problem that would which caused it to process non-KEX messages that were sent before the completion of key exchange after key exchange was completed. So that, sorry, yep, hit the mic. I think that the sort of notion there is that this expands the attack surface that the attacker gets to play with in the protocol, and so it's worth fixing. So extinfo is RFC 8308, came out a few years ago, patches up some missing extension capability in the SSH protocol. SSH has an excellent extension mechanism that served us very well, but a few things needed to be added, and this was how we did it. I guess there's two fields or two extensions that could appear in that message which are pertinent to the Terrapin attack. One is server sigalgs, which is a way for a server to tell a client what signature algorithms it will accept for public key authentication. This is used, for example, by servers advertising their support for RSA SHA-2 signature algorithms, which were not part of the original tranche of SSH RFCs. It's also used for a number of vendor extensions, including the second one there, ping at openssh.com, which is a transport layer ping primitive that the OpenSSH implementation uses to implement keystroke timing countermeasures. So we have a system that when we think that there's a human behind the keyboard and they're typing interactively, quantizes the time that packets are sent and sends chaff packets for a period after the user stops typing, and those are sent as ping messages so that they kind of simulate keystroke echoes coming back from the other side. Deleting those two messages could possibly have an impact for the deleting the server SIGALs might mean the user downgrades to a weaker signature algorithm. It's unclear what that impact that might have. This part of the connection is encrypted and integrity protected. So the attacker has no visibility into that signature. The signature's made over an ephemeral value. So there's no clear path to collision. So that's probably irrelevant. So the other thing they can do is disable the keystroke timing countermeasures in OpenSSH, which was a very new feature at the time. So quite limited impact, but it is a channel integrity break on an encrypted transport protocol. So I think it's worth fixing. I mentioned that there's additional criteria that the attacker needs to hit to successfully exploit this. And the big thing is that they can't be using a stateful transport cipher MAC combination. So if the deletion of the ciphertext after key exchange completes desynchronizes the ciphertext, then the attack will fail. SSH transport has a number of effective binary packet protocols depending on the cipher or AEAD and or MAC in use. The original one used a construction called encrypt then MAC, which is quite unsafe with CBC mode ciphers. That turns out to be safe against the Terrapin attack, as does the original counter mode. It's fully stateful. Any desynchronization will corrupt the key stream and decrypt to garbage. So that won't succeed there. AES-GCM was the first AEAD introduced to the SSH protocol. It turns out to be safe because it does the thing that I think the SSH protocol should have done originally, which is reset the sequence number each time key exchange is complete. It uses an invocation counter that resets to 0 when it gets rekeyed. So AES-GCM is safe. The CHA-20 Poly 1305 AEAD is an OpenSSH extension which is supported by a lot of other SSH implementations because it's a very fast software stream cipher /AEAD construction. It turns out to be vulnerable because it is stateless. The sequence number is an input. It's used as an initialization vector for the cipher, and because it's stateless, the damage that the attacker repairs by deleting messages gets fully fixed after key exchange. Okay, I'll leave them. Yep. Thank you for the reminders, Bob. I do appreciate them. There's also some encrypt then MAC modes that OpenSSH supports, not as widely supported among other SSH vendors. These basically use to change the ordering of the MAC. One of those is almost broken. Well, one of those is kind of broken. I think it's the CBC mode with encrypt then MAC, which is turned off by default anyway. The fine print there is that in CBC mode, a deletion will corrupt the subsequent block, but not fully desynchronize the key stream. So with some probability, you can achieve this deletion and the corruption in the subsequent message is such that the protocol can recover, but nobody should be using CBC anyway at this 2025. So fixing this, so this was part of a coordinated disclosure that occurred in late 2024, 23. One of these years' time is broken now. So we needed some fixes that were quite minimal to the protocol that could be deployed quite quickly but were comprehensive in fixing the attack. And so we selected two things that we could do to prevent the attack and basically remove the side effects that it depended upon. So the first one of those is terminating the connection if any non-key exchange message is received during the key exchange phase or re-key exchange phase. The RFC 4253 had a sort of allow list of messages that could appear in key exchange, which was quite broad. We basically shrunk that just to the bare minimum. I'll talk about each of these in a moment. And the second one is resetting the sequence number every time that the key exchange completes. So the first thing, terminating the connection for non-key exchange messages. This is like the crappy knockoff version of full transcript hash. So rather than like hashing everything that is sent, we just don't allow anything that won't be included in the hash. So it's strictly not as good. For example, you could, if you were to append data to one of the allowed messages, that would not be included in the hash, and implementations may still misbehave based on that. But I'm not aware of any attack there. And the other thing, resetting the sequence numbers, this basically means that there's no nothing persists across key exchange boundaries anymore. The protocol doesn't maintain that state. Strict hex is signaled in a similar way to RFC 8308 extinfo. So this was done by a bit of a clever hack to the protocol, because there's no fields that we could use in the initial key kexinit message that we could put an extra negotiation into that wouldn't cause a bunch of connections to drop it on the floor as unrecognized. So we put a marker pseudo algorithm at the end of the kex algorithms list. So this is the list of key exchange cryptographic algorithms that the endpoints accept. So this goes at the end of the list, is never negotiated as a winner. If it does win, then the connection fails. But if both ends have this marker in that algorithm, then the strict kex extensions are enabled. And this was, I think, quite a successful coordinated disclosure run by the research team. Most open source implementations picked up the modifications very, very quickly. By the time of their disclosure, I think everyone that I was aware of had them in time. So I think, in terms of getting the fix out there and deployed, it was a bit of a success story. It was small enough that downstream vendors were able to backport it and apply it fairly trivially to even quite old versions of OpenSSH, at least. So this is the one I'm familiar with. And I think I think we got the balance right in picking a minimal intervention that could be deployed widely versus trying to shoot for the sky and do a full session transcript under disclosure conditions. I hope I've convinced you that the Terraprint attack is interesting and the fix is worthwhile. I think the fix is worthwhile even if implementations don't support the cipher which was most vulnerable, because the problem still persists. It's putting this, there is still state that persists across a key exchange where I think that's bad cryptographic hygiene and should be avoided. And I think I've already talked about everything on this slide, except that I'd like to do a full session transcript when we get round to looking at the key exchange. There's a bunch of other stuff. I noticed Deirdre mentioned moving to a standard KDF for key generation after kex. I think that's also a really good idea. So that's it for this one.
So when we do a full transcript hashing, we can call it RSSH, really secure SSH.
It's just RSH. It's
yeah.
That's not used, right?
Okay. Any questions or comments for Damien, or for the group? I mean, we're here together.
Paul, sorry, I did not read the draft you actually wrote on this, so this is probably a stupid question, but what do you do if the client and server don't agree on the strict kex extension?
Then it doesn't get activated, and they proceed without the countermeasures. Both ends proceed without the countermeasures.
But for instance, is there guidance in the document that says if you end up using polychacha, maybe abort the connection or something like that? Or
There's no guidance in the document at the moment. That could be added. I personally don't think that the impact is sufficient to warrant that, but like we'll see what the consensus is.
Yeah, I think in principle it is a great question that if a server detects a vulnerable client or a client detects a vulnerable server, what to do? Make the best of the situation, set fire to it. Yeah, it's there's a number of options.
So there's a like I think one of the challenges here is that if you want to like the server and the client can send their KEXINET messages simultaneously. So neither can really, and there's no do-overs. So they kind of have to make up their minds straight away, and their only option is to drop the connection. They can't really, you can't fall back. I mean, you could fall back, but it incurs half a round trip to wait for the other end to send something and then make up your mind.
Hi. Yeah, Guiling here. Yeah. So my question is that, okay, the talk is very nice, very comprehensive. Yeah, talk at different angles. So my question is just, okay, for such kind of the repair fix.
Can you twist the
Close?
microphone a little bit?
Okay.
Yeah.
Okay. Oh, thank you.
Yeah, perfect. Thank you.
Yeah. So my question is that, do we need like invite some academic experts to have a review or something? Yeah, for the fix. So to guarantee, okay, it is really good, or even form analysis if necessary. I don't know. Make it complex, maybe, but
I would absolutely welcome competent cryptographic review of a more comprehensive fix to this. I think it's 2025. We should be formally analyzing our protocols. Does that answer your question, or did I miss
yeah, my question is that do we need to invite some more academic experts to have a look,
yes,
or even make some formal analysis if necessary?
So I think as part of developing the strict KEX mitigation, it was done in dialogue with the original academic reporters that flagged oh, hey, there's an issue. So the proposed solution, in fact, was discussed with the very same academic group that found the original issue. And yes, anybody is welcome to comment on this draft. So if people have access to a specific department in a university that is on top of things like these, then send the draft to them. Be like, hey guys, we go review.
Okay, that's great. So maybe later mailing list or somewhere to mention, okay, what is the main comments from them? Yeah. Okay. Thanks a lot.
Thank you.
Thank you. Next up.
No, sorry.
How do you pronounce your name?
Deirdre.
Thank you.
Yep, just kind of upping what we said in the chat that if we look at a full transcript hash for a future version of SSH, it would probably be very performant. I just kind of wanted to highlight that putting more stuff into a full transcript hash, also using a real, quote, real secure KDF instead of, a raw hash function is quite performant nowadays. So it will not bite us performance-wise to do, the more robust design in a future version. Yep.
Agree.
Next up is Gulin.
No, it's John.
Yeah, John Eriksson, I think this is a good short-term fix. My current experience is that it's hard to use this mandate is in real world because it's not supported anywhere. Ericsson of the Terrapin, Ericsson took the decision to disable ChaCha20 everywhere, which is sad, but that's just the only solution we saw. can be discussed how serious the attack is, but if you have AES GCM, there's no reason to use Cha-Cha. So we are not planning to enable that again until it can be done securely in some way, that we are sure to work interop with everything.
So my understanding is that most of the implementation of LoRa has this strict kex at openssh.com fix in there. So we are not in the hurry to actually fix this now in such sense, but that we actually need to have something that is really, breaking. We can actually, do things also differently. The question there is that if we actually want to move to this full, KDF hash of the transcript, I think we could also do it by making this, full hash as a new, kex method. And if both of ends propose that, then we would start using that. That would actually give us, protection against this, and it would also give, other features that you were liking. So that would be still backward compatible because if one end only proposes it, we do normal hashing. Or calculation of the hash. If both of them propose it, then we do the full transcript packs.
Yeah, look, I think if and when I'd certainly want to do a full transcript hash key exchange and fix a few other things while we're in there. I think regardless of when that happens, the stuff that is in strict kex, I believe, is things that should happen anyway. I think we should not be liberal in what we accept in anywhere in the pre-authentication phase of SSH. I think that's just inviting trouble. And I think not resetting the sequence number is clearly state that persists across trust boundaries in the protocol. So I think we need to, that's all worth fixing. And I guess I would expect a full session transcript key exchange specification will probably take years, months to write, a similar amount, like many months to discuss and talk about, and an unknown amount of time to engage with the academic community and get, hopefully get a machine checkable model out of.
So I wasn't proposing changing any of the actual kex. I was proposing just changing the function that is, in addition to the normal, thing, we could just add an extra step there that, okay, add also the full transcript hash there in the full transcript, of the kex to the currently calculated values, but still use the same kex method that we have before.
So just having new kex methods with a -ft at the end.
No. I was thinking about having the old kex methods, but having this one extra kex method in the end, like we have now the strict kex. That strict kex currently modifies the kex already.
Yeah.
So I was thinking about having another modifier that would say the use full transcript hash. The reason I'm actually thinking about that, because now we have, if we are going to go to full transcript hash in the future, then we have two solutions to already do the same problem, because we have two fixes. Sorry, we have two fixes. We have the strict kex and we have this, and we only need one.
Right, but what I was saying was that I think the full transcript would include these anyway, so it would be a superset of these changes. Yep. Theo.
I want to agree with Damien as to how long it would take to probably build a proper new kex. And in the meantime, people are still going to run sessions against servers which are 10 years old, 15 years old. So by making cipher changes, we've encouraged people to now have systems which actually have the strict kex fix in them. So why not just use the strict kex for safety until this other work finishes many years from now?
David Skenazy, Google. Pretty much what Theo said. I think there's value in both of these documents, but it makes sense to separate them because they have different timelines. So this solves a real problem, like an urgent problem. And so we should do it if this makes sense. And then if we want to separately and even in parallel add more things to the Scramp script, that's a reasonable idea. But like you say, that might take more time. So documents aren't free, but they're cheap.
What do you think, Joe?
Deb was before me in the queue. So.
I guess I'll just responding to that very quickly. I think the other thing that an RFC does is provide a very clear signal to implementers that this is something that they should do. So, Deb.
So when we wrote the charter originally for this working group, the idea was to start with what you were doing today in the short-term work, and then later, once things were established and the community was working nicely together, then you start working on more substantial items like this. As you say, I mean, the SSH community runs on equipment that's sometimes decades old, right? So we do want to be careful that we're not breaking people at the same time we're fixing things. But it would, to take this work on now, would require a recharter.
By this work, are you referring to full session transcript?
Yes, yes,
Okay.
yes. No, the strict CAC stuff you are doing today, and we should document that as a, here's where we are today. But if you want to do full session transcript, then I think we're rechartering, which I wouldn't want to do
Bingo.
right away, right? So we can think about this. We do need to straighten out the way this community works together first.
Job Snyders, as just interested individual. I have 2 points. Point one would be to you as author. You could include a section like future research where you highlight like, hey, this is one approach to mitigate the problem that was observed, but future work could include a full transcript. Like it is possible to leave to-do items in RFCs for future generations, what they should focus on. So in this particular case, it might be useful to highlight. Like, there could be other architectural approaches.
I think that's actually in the security considerations section already. I think I put it in there.
Okay.
I'm not 100% sure. It was written in a fugue.
And then I had a question for John. John, I think you where are you? You said Ericsson disabled Poly. A question of clarification. Even with this new extension that indicates, okay, we're doing a stricter dance, does it still need to be disabled in the assessment of your organization? So I get that disabling Poly as is might be sensible, but if this draft somehow still precludes you from enabling Poly Chacha, I'd be very interested in what the blocking factor is.
No, if this standardized or non-standard, if we could negotiate this with all the devices we need to talk to, that then we could enable Chacha. Yeah, it's more about the deployment in all the devices.
But your implementation is offering this as during the negotiation as one of the options, right? You cannot.
Yeah, you can't know before you connect, and when you connect, it's too late to back out.
But as part of the
yeah, your only choice is to abort.
So SSH negotiation of ciphers works out that you send the list of supported ciphers, and then they take the client list and check out the client's first cipher. Is it supported by server? Yes, we pick that one. Period.
Right. So the question
which
is,
means that if they offer OpenSSH, and they can send those simultaneously.
Yes.
So they can see the other's proposal before they have to pick their own.
So I guess the clarifying question is: would a future version of the implementation use this draft's mechanism and signal that strict is available, or is there some issue that prevents the implementation from using?
Just deployment, is it? Is it just the availability of it in the endpoints that you care about? Yeah.
Okay. Thank you for the clarification. Any other questions, comments on this topic?
So Damien, are you planning to ask us to do an adoption call for this at some point in the next while. I presume you are, but just may as well check.
Do I have to ask? That's a question. I don't know. I ask.
Okay, there was a bit of a hiccup in audio. What is the question?
That the working group adopt the draft.
Okay, yep. Yep. Thank you so much. Do you just want to stand on the stage, or do you want to walk back and come?
I don't have a curtain that I can walk behind. Put on a fake mustache and.
All right. Certificate format.
All right. Oh, do you have to...
And the clicker is links.
Okay, let's see.
Take it away, Damien.
Okay. All right. So the original SSH RFCs didn't eat the mic. Okay. The original SSH RFCs didn't properly specify certificate format. There was OpenPGP based formats listed in there, but there was no information on the syntax or structure of what those keys were supposed to contain. So there may have been some attempts to implement those, but I've never seen them on the wire. Much later, there was a RFC for X509 certificate use in the SSH protocol. Much more information. I think probably still lacking a bit of guidance for implementers on how to semantically interpret those and map, for example, and map a certificate to a user account, do the authorization, etc. Very few implementations support either. There's a patch, it might be a separate standalone product, used to be a patch set to OpenSSH. I think maybe some of the commercial ones support X509, but that's about it. So in 2010, I wanted a certificate format for SSH. I wanted it to be simple. I wanted it to be flexible, and above all, I wanted to be able to add it without massively expanding the attack surface, because I read a bunch of ASN1 and X509 code, and I didn't want that anywhere near the pre-authentication phase of OpenSSH. So, and by simple, I mean simple syntactically. X509 uses ASN1. ASN1 can contain near arbitrary syntax there's the famous certificate that contains a cat video. So I wanted to use SSH wire encoding primitives for the format. I want it to be quite a fixed format with a well-defined structure, and I wanted it to have a extension mechanism, which was in the spirit of the other SSH experiment extension mechanisms, where vendors with protocol format objects were identified by text strings and could have domain identifiers for vendor extensions. I wanted it to be semantically simple as well. We're not trying to build a global namespace out of OpenSSH certificates. We're trying to build at most an organizational level namespace. We didn't see a need for a multi-level certificate hierarchy, and principal names in the certificate are just strings and have significance only between the CA and the endpoints that consume them. So this is all in one organizational scope. We can hopefully agree within one organization, though I know that's hubristic sometimes. So this is the certificate format. Like, this is an example of a certificate for a ED 25519 EDDSA certificate. I'll just go through all the fields fairly quickly. First is a key type name. This is very much a standard part of the SSH key format. Every key has a type name. The plain key, the plain uncertified peer to this would just be SSH-ED 25519. So this is basically the thing that the key parsing switches on to figure out what to do next. Random nonce specified by the CA. Intention there is that there's things that the client may have specified to be in the CA this would make it harder to do hash collision attacks. This is the plain key blob. So the certificates wrap a plain key with some identity information and a signature by a trusted CA. This is the plain key that's being wrapped. It's encoded using the standard SSH key blob encoding for the key type. So I can't remember which RFC number does EDDSA, but it's fully specified what goes in there. Serial number specified by the CA, useful for logging, revocation, etc. Type, at the moment, 2 certificate types are specified, one for user authentication, one for host authentication. Those are the 2 places that keys are used in the SSH protocol. And so this is domain separation for each key usage class. Key ID is human readable and for logs, not for authorization decisions. I think we may also use it in revocation as well. This is the list of certificate principals. It's just comma separated strings. For users, it is names of whatever format work for your organization. Typically be usernames or user at domain are both common. For example, at work, we have user and user at Windows domain in the same certificate for various classes of hosts, obviously. For host certificates, host names and or IPv4 or IPv6 or whatever other addresses you might be using. Again, it can be a list of multiple, so wildcards are not supported. Some validity information. There's 2 special case values. A valid after of all 0 means that it has infinite validity into the past, and an all ones value means it has infinite validity into the future. So there's no, I don't know what the int64 version of the year 2038 problem is. There's no problem with it. There's no problem there. The next 2 fields are like the extension section of the certificate. We separate the critical extensions from the non-critical. If a implementation does not recognize a critical option, then it's required to disallow the certificate. So generally in here things will appear that limit the scope or usefulness of the certificate, impose additional authorization constraints, etc. So, for example, in one of these that's defined, used by OpenSSH, is this certificate is usable only from these address ranges. So if an implementation didn't understand that, it'll drop it on the floor and fail safe rather than fail dangerous. Extensions is the other one of these. It's defined to fail permissively if an extension's not recognised. Both of these fields, the critical options and extensions, are basically key value strings in an array, and the defined order is lexically sorted by key. So the structure is canonical. There's a reserved field there as a get out of jail free for the inevitable things that we've missed in the future. Implementations are required to accept stuff in the reserved field that they're not familiar with. And this is the key blob for the signing CA, again encoded using the standard SSH blob key blob format. And then the signature is made over everything from the key type name at the top of this list down to and including the signature key of the CA itself. So everything up to this point gets signed, and that's the signature, using, again, standard SSH signature encoding rules in RFC 4253 and so on for the other algorithms. So for implementing this in OpenSSH, added oh yeah, sure.
If you go back one slide for a second. So type is in some sense key usage, but there are just 2 key usages defined. Is that correct understanding?
That's correct, yes. Just two key usages.
Okay, and the first line is essentially the algorithm identifier just encoded in a somewhat unique way. Is that fair to say? Because the SSH, it's obvious. So the real relevant information in here is that it's ED25519 base key. Is that correct? Because yes, that's then later used, for example, for the public key to determine the encoding of the public key. Is that?
Yeah. So this determines how this line is present in all SSH format keys, not the particular string contents, and it's used to determine what the contents of the remaining contents of the key are. And most SSH implementations will either negotiate what keys are supported in a given context, or will happily accept keys that they don't understand and just disregard them. So it's mostly fail.
And then the signature key is that the public key of the CA with that, or the reference to, or hash of, or the name of the CA public key, or
that is the full CA's public key.
And it would be in the same format as the this key. Okay.
Yes, correct. Yeah.
Thank
you. So adding this to OpenSSH was under 600, maybe definitely under 1,000 lines of code. The sort of core parts of it were definitely under 600 lines of code. We implemented a minimal CA in SSH keygen. CA trust anchors are specified in OpenSSH using the existing kind of places people specify key trust. So for host trust in the known host files, and for users, that has to be done through the server configuration. There's a way to map. You can either just accept a default mapping that for user authentication that the certificate must contain usernames directly, or there's an indirection mechanism that allows you to use arbitrary names in there and map them to user accounts. This was added in 2010 and has steady adoption across implementations, other implementations since. Not every implementation supports it, but certainly a plurality of SSH implementations support it, as well as a number of third-party tools and things that have built upon this. So Small Step CA includes an SSH certificate CA. I think there might be another one from Uber. And there's a system called Heba, which is a host group access control mechanism that from Google, which builds upon this, and vended certificate extensions to allow sort of certificates that declare that the user is allowed to access this particular group of hosts centrally. So at the time this is obsoleted by the last 3 days, because after writing this this slide deck, and in the same fugue in which I wrote up the strict kex, I also converted the old protocol.cert keys into an internet draft and dumped it on poor Job and Stefan. So that's on the list, and if you want to look at it, it's all there for your dissection. That's it.
Thank you so much. I did pick up some questions from the chat. Can you go back a few slides to the overview of the primitives used in the format? Yeah, that one. Yeah. The extensions. So the question from the chat is along the lines of, hey, extensions is a string, but it sounds like it's a list. How is the list constructed? Is it comma separated, or is there?
Right.
Do you put ASN1 in the string, or?
Obvious troll is obvious. So it's a string that embeds 0 or more. And this, when I say string, it's a SSH protocol string, which is like, it could contain binary or text. So the extension section is a string that in turn contains pairs of 0 or more pairs of key value strings. So on parsing, an implementation would typically pull out 2 at a time until that string is exhausted. That's what OpenSSH does anyway.
Thank you. Any other comments or questions on the topic of certificate formats? Daniel.
Thanks for this overview, and thanks also especially for turning it into an internet draft. I appreciate that. Can you talk a little bit about the extensions and the reserved, and whether it's possible to do something like critical extensions. Like if I'm interpreting one of these things and I find an extension that I don't understand, what is the expected behavior, and does it conform across all the implementations?
I haven't. Well, answering the last thing first, I haven't read all the other implementations, but critical options is defined to do what I think you're asking. If an implementation doesn't understand or doesn't support a critical option, then it's required to disregard or disallow usage of the certificate. And extensions has the opposite sense. So if that's not recognised, then certificate processing can continue. I think the first part of your question is what we've actually got in those things. Critical options has a source address allow list in OpenSSH. It has a force command facility where you can define a certificate that it can only be used to execute a particular command. It has another option relating to the use of FIDO keys in SSH, which is an OpenSSH extension, which says you must have the signature to accept this certificate. The signature made by it must assert user verification, which is a FIDO flag that means that someone's done their fingerprint or typed in a PIN. For extensions, it's generally things that permit things, so that if they were disregarded, then the connection would continue fine. That includes things like permitting PTY allocation for interactive programs, permitting agent forwarding, permitting X11 forwarding. So all of these forwarding things that are in the SSH protocols have a corresponding permit flag. And there's a FIDO, OpenSSH FIDO one, which is turns off the requirement for FIDO keys to assert user presence. I said user presence earlier. I meant user validated or something. User presence means you've touched a FIDO token to demonstrate that you're there. That's on by default in the OpenSSH extensions, which I'm sure I'll present one day in about 3 years. Yeah, does that answer your question?
It does, thanks. It also makes me think that at some point, an internet draft like this is going to be incomplete without some sort of registration of the extensions, which it just starts to get to a more heavyweight ask for IANA.
Yes. So the draft that I wrote up documents the current extensions and requests the creation of an IANA registry for tracking those in the future.
Hi, I have one question for the key ID and also for the nonce. The key ID, is that just a human readable description and it's actually not used in the protocols to refer to the key, or is it both?
That's it. It's a human readable description. That's its intent. Yes.
Okay. And there's no need to refer to the key by some identifier?
So I've completely not talked about revocation here. In revocation, you may want to refer to a key by serial number. So more specifically, CA, serial number tuple. And there is I'm not proposing it for specification, but there is a corresponding key revocation list format in OpenSSH, which allows efficient revocation of ranges of serial numbers and other stuff. So you can like the simplistic solution for revocation is you just revoke individual keys explicitly, but you can revoke by you could revoke by serial number, and the intention of serial number is to appear in logs and for revocation.
So the unique identification of a specific key would be, since the CA also has no name, it would be the public key of the CA plus that serial number. Is that fair?
Yeah, public key of the CA plus the serial number.
Okay.
Yes.
And the nonce was a little bit mysterious to me because it's not really a nonce, it's just random data. But normally you shouldn't, if you use a proper hash function, you shouldn't need a random component in the certificate.
Yes, yeah, it's a defense in depth thing, and we've lived.
Depends
through,
on how you select the serial number, because that could be random as well.
CA specifies.
Okay.
Yep.
Yeah, we've lived through SHA-1 deprecation in the SSH protocol, so we've already lived through one kind of broken hash function, and MD5 before that, really. But
So, what did Joe? I thought Joe was in front of me. Did you pop yourself down?
I want to talk about a slightly different topic, so
Okay.
please.
So, what about algorithm, like signature algorithms? You know, are they always ED 25519 and not just?
no, this is sorry. I should have clarified. This is an example of a particular instance of a certificate. We would every SSH key, at least in OpenSSH, every SSH key format has a peer certificate format. So you could certify, you could certify an RSA key, an ECDSA key, a DSA key if you if you hated yourself.
So how do you know which it is?
So let me back up.
Sorry.
That string.
Oh,
will be
that
different.
tells you.
Yeah.
Okay,
and
so
then,
that value changes.
And
okay.
then that value also contains a key type string, and they have to match.
Okay.
Yep.
Oh, so there's more here than.
Yeah.
Just...
So that PK actually is the key, the inner key blob of the public key material.
Okay. There's something else I wanted to ask. Shoot.
You can come back in line.
I can.
Scott.
Scott Fleur. The signature key, you said it was the full signature key of the CA. Recommendation: I make that a hash of the signature of the CA's key. For ED 25519, it's no big deal. It's tiny. Once we go into MLDSA, they're no longer tiny.
Fair point.
Job Snyder's as individual.
Oh, hang on. We could use seeds?
Two small comments. In skimming through the draft, you outline the what do you call this format of string and uint? Is this a
this is the SSH wire encoding format? I think it's RFC 4250 or 51.
Right. So in it might be beneficial to include a number of actual examples, say base 64 encoded, so that you can pull them out of the draft or RFC and test for compliance.
Yep.
From my experience in the RPKI, when we have assigned objects, including an actual example of such an object seems helpful. So that was point one. Point two, in X509, we have the version field, and it's very intuitive. When we talk about version 3, we encode the integer 2. Can we also have a construction like that in SSH to add confusion?
Yeah, so we can change the name if there's another version.
So the name is the version field.
The name is the version field.
Okay.
Yeah. Yeah. So this you can. Yeah, you can see that this is V01. There was a V00. It was never released. Yep. But if we need to rev it, we could rev it. This format has been stable for 15 odd years now, so it's it filled the purpose for the people who use it at least. But that doesn't mean that other people might have things that can't be represented in it. I mean, I aim for simplicity to the point of being simplistic in creating this format. So,
thank you. Any other questions or comments? We have 90 seconds left in our session. All right. Well, that brings us to the end of the second SSHM session at IETF. I thought it was fun, so I hope to see all of you in Madrid at IETF 123 in July 2024. 25, yeah. Thank you all for participating, and I wish you an excellent day.
Thank you.
Thank you.
That's what I'm saying.